Okay. Let me just double check it's recording. Yes, okay. Okay, so for this chapter, we're going to go over the supplemental lesson number 2, which talks about Euler's method. And we're mainly going to do this when we cannot like separate or use the first order linear for a differential equation. And so I feel like it's pretty straightforward once you start doing some practice problems. So I can't really think of anything beforehand except for like you will want to have this down. Um, and I guess the only other thing to really know is that we use Euler's method to find like an approximation. And then what we could do is we could just compare the accuracy of the approximation to like the actual equation. So it's just another technique that we've learned. And yes, I guess I'll get started. I'm also going to refer to the problems in the homework. Um, and so we'll just go over just a few because I don't want this video to be long as well. I think we'll just do a practice problem and then maybe like a word problem. Okay, so I think this one's good. We're just gonna do number 1. So for number 1, it says consider y prime equals 7x minus 2y, and you have y of 3 equals 6. It says use Euler's method with a step size of h equals 0.5 to find the approximate value of the solution at x equals 4.5. Oh, sorry. Okay, so the first thing we're going to do is we're going to write down the information that we have. So we said that our y primed is 7x minus 2y. We said that our x of 0 and y of 0 is going to be 3, 6, which comes from, you'll usually see this in a problem, y of 3 equals 6. Comes from that. And then the last thing we want to note down is our step size. And for this one, it is 0. So I feel like that is like our step 1, just writing down the information. The second step that I usually do is I like to write a graph. So I'll just do this x, y. I feel like this graph is going to be really helpful actually. So we're going to plot the point 3, comma 6. So 3, 6, 3, comma 6. And this is going to be our x of 0, y of 0. So it's our starting point. So, oh, and I forgot to write down one other thing. So it wants us to find approximate value for or at x equals 4. Okay, so this is kind of crucial because this is essentially our endpoint of x. So we want to get to 4.5 and we are at 3. So like how long will it take us to go from 3 to 4.5? And we can't just go like a full like number. We have to go 0.5 because we are given our step size here. So what we're going to do is we're going to do 3. We do 3.5, 4, and 4.5. So that's what will get us to 4.5. And then I like to write down, this will be our x of 0, x of 1, x of 2, and x of 3. Okay. So now we're going to start, I guess, like the third portion. And I'm going to write this down right here. we want to go from x of 0, y to 0 to our x of 1, y1. And so how do you do that? Well, I feel like this is like an equation you maybe want to memorize. So we're going to have our y1 equal. We're going to do y1 x of 0, y of 0 times x of 1 minus x of 0 plus y of 0. And then the crucial part about solving these problems is making sure you have like the right part in the problem, like you're not mixing it up. So we have y of 1 equals, so our y1, we are actually going to compute that, I believe, off to like the side. So to find our y of x 0, y 0, we're going to plug in our starting point, which is 3, 6, to our equation 7x minus 2y, which is going to be, let's see, 7 times 3, 21, minus 2 times 6. And that's just going to be 9. So you could do that off to the side. You could also do it in the problem. I mean, whatever works for you. I think I'll just do it in the problem to begin with so it is a lot clearer. So we have 3, 6, and we're just going to do 7x minus 2y. And do plug in. And then we are going to take our x1, which we actually go up here, and this is going to be our x1. And this is why I write it down, because I feel like it helps visually just to understand everything. So our x1 is going to be 3.5 minus our x of 0, which is 3, plus our y of 0, which is 6. Because from our initial x of 0 and y of 0 is 3, 6. Okay, so we already figured out that it is 9, but I guess we'll just write it. And then you're going to go, so 3.5 minus 3 is just going to be 0.5 plus 6. And then if you do 9 times 0.5 plus 6, that is going to be 10.5. So we have now figured out our x1, y1, which is going to be x1, we go up here, 3.5, and 10.5. Okay, so now we figured out our y1, and we just have to figure out our y2 and y3. So we're basically going to do the same thing over again, our y2, but we are going to change these up a bit. So before we wanted to find like our x of 0 or y of 0, but now that we've already used that and we found our x1, y1, we're going to change this up just a little bit for our y prime to be, we're going to use our x1, y1, times our x2 minus x1 plus y1. And then we are going to do the same thing, which is 7x minus 2y. And we are going to plug in our, let's see, x1, yeah, we're going to plug in our 3.5 and our 10.5. Our x2, we go up here, is 4. 4 minus our x1, which is 3.5, plus 10.5. Okay, and I think this is where it's acceptable to like whip out your calculator, just to make sure it's all correct. We're gonna have 24, 5 minus, which is gonna be 21. This is usually, like, for this part, is going to be just 0.5, but you could just compute it just in case. But it should be 0.5. Okay. And then we're going to reduce this down, and this should be it should be 12.25. So we get our x of our x2, y2 is going to be you go up here, x2 is 4 dash 12. Okay, so we're almost done, but we just have to compute our y3 to find our x3 and y3. So we're going to do the same exact thing again. But this time we're going to use our x2, y2. We're going to find our x3 minus x2 plus y2. And then we're going to do, let's see, it's 7 times 4 minus 2 times 12.25. It's going to be 4.5 minus 4, I believe. Yep. We got the 4 from right up here. And then plus our 12.25. This is going to equal 28 minus 24.5. 0.5 plus 12.25, and this computes to 14. So our x3, y3 is going to be 4.5 dash 14. And that's it. And this is how we use Euler's method to get a nice approximation. Okay, so because of time, we're just going to do one other one very quickly, but I feel like just with repetition, you'll be able to just kind of get it. So we'll just do another one. Hopefully this video isn't long as well, but I guess we'll see. Okay. So it says, sales of a popular new computer game are growing so that the number y of t in thousands sold in the first t months satisfies y prime equals 2e 0.05y plus 2y. And you have y of 0 equals 0. Use Euler's method with h equals 1 to estimate y of 3 and include appropriate units. Okay. So the first step again, we're just going to list everything that we have gotten from this equation down. So we know our y prime equals 2e 0.05y plus 2. Our x of 0 and y of 0 is going to be 0, 0. Now we do have a, excuse me, we do have, what's it called, an h step? A step size of 1. So 1. And then we want to get to y of 3. Okay. So next thing we do is we make the graph. It doesn't have to be perfect. It just want to use it to help you. This is our x0, y0. And so unlike before, we're not going 0.5 over, we're going one whole number over. So we got 0, got 1, 2, and then we want to get to 3. So 3. So 1, 2, 3, so 0. This is going to be our x1, x2, and x3. So this is our final point. Okay. Now, same thing as before. The only thing we want to be careful about is what we plug into where. So we're using or we're getting the right number each time and we're not mixing things up. So we're gonna find our y of 1. 1 equals y prime of x of 0, y of 0, because it's given to us. X of 1 minus x of 0 plus y of 0. This is going to be, so I feel like I might compute this off to the side, but we might I'll just do it here. Since our points are 0, 0, it's going to be, oh my gosh, where is it? Okay, 2e 0.05 times 0 plus 2. Our x1 is just 1 minus 0. And our y of 0 is just 0. So we should be able to reduce this. E to the 0 is just 1. So it's just going to be 2 times 1, which is 2, plus 2, times 1. 1 minus 0 is 1, plus 0, which is just going to be our, oh my gosh, sorry, I can't talk. It's just going to be 4. And so we have our x1, y1 equals 1, 1. And that is the first part. Now we just have to find the two others. So we're going to do the same thing again. Find our y2, y prime. We're going to use x1, y1 because we just found it. x2 minus x1 plus y1. Then we are just going to plug everything in. This time we're going to use the points 1, 4 to get 2e 0.05 times, is that y? Times 4 plus 2. And then we're going to have 2, because x2 is 2, 2 minus 1. I got that from right here. So I'm referring to, like, when I refer to my x1, x2, and x3, I'm referring to these numbers. And then it's going to be plus our y1, which is just 4. Okay. I think for this one, I'm going to use the calculator, because, let's see. Hold on, am I doing this right? 2. Okay. Yeah, so I computed this equation first and then I computed the rest. And when you do this on your calculator, you should get, see, 8.4428. I'm just gonna round it to that. I mean, there are other numbers, but also when you're doing a problem, it should tell you how much to round to. Okay, 4 decimal points for this. Okay. So just gonna be that. And now we found our x2, y2, which is equal to 2, 8.4428. And when you get like more decimals, that's better because it means like it's a better approximation. So like you're on the right track. And then we're just gonna do the last one, which is y3 equals y prime plus x2, y2 x3 minus x2 plus y2, which is, yeah, 2e 105 times 8.4428 plus 2. 3 minus 2 plus 8.4428. When you calculate all of this, you should get 13.498. Or using the right decimal places, you will get your x3, oh my god, y3 to be 3 because our x3 is 3, comma, 13.4932. Okay. And because we're looking at, let's see, the number in thousands sold in the first T months, this is our X is going to be our T months. So because this is a word problem, we want to write it out. So we would say at 3 months, 13.4932 thousand units, oops, were sold. Hopefully that's readable. Again, apologies if this video is long. I really did try to like rush it, but I don't know, maybe I'm just slow at talking. But yeah, that's it. I feel like the main takeaways for here, when using Euler's method is to first write out all the information for step 1. Step 2 is make a graph. It doesn't have to be perfect, but I think this will just help you in the long run to figure out your x of 0, x of 1, x of 2, and you're gonna plot each point based on your h, because you're going to want to see if you're able to move like a full step size or half a step size. So it just determines this. The next thing you're going to do is set up your equation and plug everything in correctly, starting with x of 0. This part, you're usually taking the next one minus the one you just figured out plus y of 0. And then once you get your first one, then once you go to the second one, you're just gonna plug that in again. Oh my god, plug that in again, to get your y2 and your y3. So, because we used like the 3.5, 10.5 here when we plug it in. So, just helpful to know. You see like decimals or more decimals, that's a good thing, better approximation. And yeah, I think the only thing here is just like be careful when you're plugging in as well, making sure like things cancel out or you're able to do it correctly on your calculator or not. But yeah, I hope that was helpful.